Chapter 4, Psychological Measurement. Researchers MacDonald and Martino wanted to examine how female university students' moods influence their intentions to engage in unprotected sex. Their study found that only students with low self-esteem who are in a negative mood were more likely to have unprotected sex. One of the most challenging aspects of this study was figuring out how to measure the relevant variables. The researchers had to evaluate participants' self-esteem levels, then induce a negative mood and measure their responses. Next, they needed to see if self-esteem and mood were linked to participants' intentions to engage in unprotected sex. And finally, they had to measure those intentions. If you read their original article or any other research papers, you will find that researchers are incredibly meticulous when designing studies and measuring variables. This might make you think that it's almost impossible for student researchers to replicate this level of care. Furthermore, how can we measure intangible concepts such as self-esteem, mood, or intentions? If you review past research, however, you will realize that it's actually achievable. In this chapter, we will explore the variables psychologists study, how they are measured, and some practical issues related to psychological measurement. 19, understanding psychological measurement. So what is measurement? Measurement is a systematic process that generates scores representing a person's characteristics. For instance, the Wechsler Adult Intelligence Scale, or WAIS, is one of the most widely used standardized intelligence tests. The digit span forward subtest, part of WAIS, involves an examiner reading a series of numbers such as 3, 2, 1. And the test taker then immediately repeats these numbers in the same order from their memory. The test ends when the test taker makes two consecutive errors. The digit span backward subtest is more challenging, requiring the test taker to recall the numbers in reverse order. The Beck Depression Inventory, or BDI, is a 21-item self-report questionnaire that evaluates a person's mental state, including their level of sadness or energy over the past 2 weeks using a Likert scale. The total score indicates the person's current level of depression. The WAIS, the BDI, and many other psychological assessments have undergone rigorous testing multiple times and have been validated. Psychological constructs. Many variables studied by psychological scientists are simple, like age or height, which can be measured directly. Others, called constructs or psychological constructs, such as personality traits, emotional states, attitudes, and abilities, are less straightforward because they represent the tendencies or internal processes that cannot be directly observed. For example, a student might be generally extroverted, but not acting openly at the moment, so it's challenging to assess their personality just by observing their behaviors. These constructs involve complex behaviors and internal responses, making them less observable, yet essential for understanding human psychology. Psychological scientists work really hard to describe our behaviors and internal processes that comprise the psychological construct. They develop, test, and refine conceptual definitions empirically to make them more precise and clear. So, for example, consider neuroticism, a key aspect of the Big Five personality theory, which is widely accepted by psychological scientists. It's the tendency to experience negative emotions like anxiety, anger, and sadness in various situations. Neuroticism has a genetic basis, stays relatively stable over time, and is linked to physical pain and symptoms. When studying these concepts, researchers do not rely on dictionary definitions, as many scientific ideas do not have everyday equivalents or require more precise explanations. Instead, they create, test, and refine their definitions based on real-world evidence, leading to multiple definitions that may evolve over time in research studies. Operational definitions. To test hypotheses with empirical data, researchers must develop operational definitions or operational variables based on conceptual variables. Operationalizing means turning a conceptual definition into a measured or manipulated variable that can be empirically tested. Simply put, researchers find a way to convert conceptual variables to numeric variables. There are several measurements that are used by psychological scientists. The first one is self-report measures. In this type of measure, participants are asked to report on their own thoughts, feelings, and actions, as with the BDI or the Rosenberg Self-Esteem Scale. Another example is research investigating the effect of vocal fry. Now, if you do not know what vocal fry is, I want you to pause this lecture video and search vocal fry and Kim Kardashian. You know her, right? You may have noticed that some people, most women, end their sentences with low guttural vibration, similar to how Kim Kardashian, a reality TV star, speaks. Some find this very annoying. Not all, but some of them find this annoying. And the research shows that female job applicants who use this type of voice are less likely to get hired than those who do not. To examine this, researchers can ask a volunteer voice actor to record her speech with three levels of vocal fry: low, medium, and high. These levels are determined by independent coders. Participants are then asked to pretend to be hiring managers for a company and decide how likely they would hire a woman based on her recorded speech. They will be randomly assigned to one of the three conditions depending on the amount of vocal fry. So if you, as the participant, are assigning to the low vocal fry condition, you will hear this voice actor's speech with low level vocal fry. If you are assigned to the medium vocal fry condition, you will hear her speech, the same speech, with medium level vocal fry, and so on. Later, you will be asked to rate how likely you would hire her. All right, next, behavioral measure. In this type of measure, participants' specific behaviors are observed and recorded. For instance, to measure aggressive behaviors in children, researchers must clearly define what aggressive behavior looks like. Simply observing children's actions and noting when researchers think they see aggressive behavior is not effective. A more useful and clear approach might be to track the number of times a child physically pushes, hits, kicks, or punches another child. This type of variable is straightforward and can be measured objectively. However, observers must be well trained before collecting data to ensure reliability and validity. Next, physiological measures. Physiological measures involve recording a range of physiological processes such as heart rate and blood pressure, galvanic skin response, hormone levels, and brain activity, including electrical activity and blood flow. Consider the following example. Literature suggests that people develop empathy toward inanimate objects, such as a toy capable of holding a conversation using AI. To test this, some participants are asked to interact, play, and have a conversation with a toy uh, for an hour. Then, a researcher destroys the toy physically with a hammer. Other participants who did not interact with the toy at all also observe it being destroyed. While watching, participants' physiological responses such as heart rate and galvanic skin response are measured. Now, typical results show that the first group who previously interacted with the toy exhibits significantly more spikes in physiological activity when the toy is destroyed than the second group who did not interact with it. The last one is converging operations. Often researchers use multiple measurements to evaluate a specific variable using converging operations. For example, different measures of stress are interconnected and have been shown to relate to other factors, such as immune system function, which is also measured in several ways. This connection enables researchers to draw broader conclusions like stress is negatively related to immune system function, rather than more specific and less useful ones, such as people's scores of the perceived stress scale are negatively linked to their white blood cell counts. Levels or scales of measurement. You have learned this in a statistics course, and there are four different scales of measurement, if you remember. The first one is nominal level or nominal data. For categorical variables, we use nominal measurement or nominal data, which assigns scores that represent category labels. These labels show whether two individuals are the same or different in terms of the variable being measured. Room number, such as room 100 or room 201, is an example of nominal data. These variables are simply names, so they don't offer any other information other than the name. Just because the name room 100 includes a number that is smaller than in room 201, it does not mean the former is larger than the latter. Another example is Nike versus Hoka. Again, these are brand names for running shoes, so the name itself does not provide any additional information beyond its name. The next level is ordinal level. Ordinal measurement or ordinal data shares all the properties of nominal measurement, but also involves assigning scores to indicate the rank order of individuals. Ranks show not only whether two individuals are equal or different on the measured variable, but also whether one is higher or lower on that variable. Examples of ordinal data include movie box office ranking and the top 100 popular songs. Next is interval level. Interval measurement or interval data includes all properties of the ordinal data, but it also involves assigning scores using numerical scores in which intervals have the same interpretation throughout. As an example, consider either the Fahrenheit or Celsius temperature scales. The difference between 30 degrees and 40 degrees represents the same temperature difference as the difference between 80 degrees and 90 degrees. This is because each 10-degree interval has the same physical meaning in terms of the kinetic energy of molecules. Standardized scores such as IQ scores and SAT scores are also interval measurements. Interval measurement, however, does not involve a true 0 point. The last one is ratio scale or ratio level. Ratio measurement or ratio data includes all properties of interval measurement, but it also involves assigning scores in such a way that there is a true 0 point representing the complete absence of the quantity. Height measured in meters and weight measured in kilograms are good examples. The measurement of temperature, Kelvin, also contains a true 0 point. 0 degrees Kelvin is absolute zero, the lowest possible temperature, equivalent to negative 273.15 degrees Celsius or negative 459.67 degrees Fahrenheit. At this temperature, there are no movements in molecules. Therefore, temperature does not exist at 0 degrees Kelvin. You should also recall the concept of central tendency from your statistics course. For nominal data, only the mode is appropriate as nominal data are categorical data. For ordinal data, the median or mode can be used as an indicator of central tendency. For interval data, all central tendencies are appropriate. However, the mean cannot be calculated if the highest or lowest interval of a group frequency distribution is open-ended. For ratio data, you can use all mean, median, mode for central tendency. All right, next, reliability and validity of measurement. How can researchers be sure that scores truly reflect a characteristic, especially for concepts like intelligence, self-esteem, depression, or working memory capacity? Your measurement must not only measure what it is supposed to measure, but also be reliable in doing so. Imagine trying to measure your weight, but instead of a weight scale, you use a tape measure. That's obviously not a valid way to measure your weight. The weight scale also needs to be reliable, meaning it should give you the same result every time you weigh yourself when your weight has not changed. When assessing a measurement method, psychological scientists look at two key dimensions, reliability and validity. Reliability means how consistent the results of a measure are. With the test-retest reliability, researchers want to see if consistent scores can be obtained every time the measure is used. For example, if you take an IQ test at the beginning of the semester, which is time one, and again at the end, which is time two, and the scores are relatively consistent across time one and time two, or if they are correlated. The IQ test you took has a good test-retest reliability. Here's another example. The graph you see on the screen shows the correlation between two time points 2 weeks apart on the Rosenberg self-esteem scale. High scores at time one tend to be high at time two, and low scores tend to be low, indicating a rather clear positive correlation. The correlation coefficient is 0.95. A test-retest correlation of 0.80 or higher generally indicates good reliability. So 0.95 is pretty high. Next, internal consistency, also known as internal reliability, measures how consistent people's responses are across the items on a multi-item measure. When a participant provides a pattern of responses that remains consistent, regardless of how the researcher phrases the questions, then you have a high internal reliability. For example, imagine a researcher asks in several different ways about how hungry you are, and let's say that you are super hungry. One question asks, "Are you hungry now?" And your answer is probably yes, right? The second question asks, "Do you agree or disagree with the following statement?" And the statement is, "My stomach is almost empty." And your answer should be, "I agree." The third question is, "I am not hungry right now." And your answer should be, "I disagree," and so on. No matter how questions are phrased about whether you are hungry and if you are actually hungry, your responses should be consistent. If so, this questionnaire demonstrates high internal reliability. Like test-retest reliability, Internal consistency is also assessed by gathering and analyzing data. One way to do this is by using a split half correlation. This involves dividing the items into two sets, such as the even and odd numbered items. A score is then calculated for each set, and the correlation coefficient is calculated for the two sets of scores. For example, this graph on the screen shows the split half correlation between the scores of several university students on the even numbered items and their scores on the odd numbered items of the Rosenberg self-esteem scale. One of the most commonly used measures of internal consistency is psychology. In psychology, psychological research is Cronbach's alpha. Alpha is the average of all possible split half correlations for a set of items. So for example, with 10 items, there are 252 ways to split them into two sets of five. Cronbach's alpha, also known as coefficient alpha, is essentially the average of these 252 correlations. While this is not the actual calculation, it gives a clear idea of what alpha represents. Generally, researchers agree that a value of zero point 0.8 or higher indicates good internal consistency. Inter-rater reliability is about whether scores are consistent across different people who measure them. This is important in observational studies, like when two observers count how often a child sneezes during an exam. If their counts match, the inter-rater reliability is high. To assess this reliability, researchers often use Cronbach's alpha for quantitative judgments and Cohen's kappa for categorical ones. When something is valid, it is reasonable, accurate, and justifiable. Validity refers to the appropriateness of conclusion or decision made by researchers. For example, I'm directionally challenged, and when I'm done shopping at the grocery store, 9 out of 10 times, I cannot find my car right away in the parking lot. My intuition for direction is almost always off or not valid, but since I'm usually wrong, at least I'm consistent or reliable in terms of directions. But I'm almost always wrong. There are several basic kinds of validity. The first one is face validity. It is a subjective way to assess validity based on whether it appears to be a good measure. This type of validity is often judged by experts, making it inherently subjective. If it seems like an appropriate measure, then it has face validity. Face validity is at best a very weak form of evidence that a measurement method is measuring what it is intended to measure. Because it depends on subjectivity, it can often be incorrect. And in addition, many established psychology measures work well despite lacking face validity. The MMPI-2 assesses personality traits and disorders by asking individuals to judge if over 567 statements apply to them, many unrelated to construct measured. For example, items like I enjoy detective or mystery stories, and sight of blood does not frighten me or make me sick. Both measure aggression suppression. The focus is on response patterns matching those of individuals who suppress aggression, not the literal answers. Content validity. Content validity is also a subjective measure as it involves asking whether the content includes all the key elements of the construct. It is evaluated by thoroughly examining the measurement method against the underlying concept of the construct. Next, criterion validity. Criterion validity examines whether it correlates with key behaviors. When the criterion is measured at the same time as construct, it is called concurrent validity. However, when the criterion is measured at a later time after the construct has been measured, it is known as predictive validity because scores on the measure have predicted a future outcome. Criteria can also include other measures of the same construct. For example, new measures of test anxiety or physical risk-taking are expected to be positively correlated with existing measures of the same construct. This is called convergent validity. Let's analyze the graphs on the screen. Suppose your clothing company wants to boost sales, so employees took a sales ability test and an IQ test. The dots in the graph represent individual scores. When comparing sales and sales ability test scores, as shown in the left graph, all dots are clustered together along the line, indicating a strong positive correlation. In contrast, when comparing IQ scores and sales, as shown in the right graph, the relationship remains positive, but individual scores are more spread out, showing a weaker positive correlation. This comparison suggests that the sales ability test score has better criterion validity than IQ for predicting sales increases. Now, the IQ score is not as bad a predictor of sales, but the sales ability test score does a better job. Convergent validity measures how well a test correlates with other tests of the same construct. This type of validity examines the similarities between two measures. For example, the left graph supports the convergent validity of the BDI with another depression measure called CESD, or Center for Epidemiologic Studies Depression Scale. The two measures had a correlation coefficient of 0.68. This is good because both are intended to indicate levels of depression. Therefore, if an individual scores high on the BDI, they should also score high on the CESD. Conversely, if someone is not depressed, their scores on both should be low. Another example is IQ test development. Every 10 years or so, publishers release a new version of an IQ test, such as the Wechsler Intelligence Scale or Stanford Binet Intelligence Scale. Before releasing a new version, publishers compare it to previous versions to ensure they are highly correlated. In other words, they verify that the conversion validity between the new and old version is high. Discriminant validity, also known as divergent validity, measures whether a test weakly correlates with measures of different constructs. This type of validity examines the differences between two measures. For example, the right graph on the screen supports the discriminant validity of the BDI with a score on physical health measure. The BDI is weakly positively correlated with physical health with a correlation coefficient of only 0.16. This indicates that the severity of depression is not strongly related to physical health. In summary, convergent validity is about stronger correlations, and discriminant validity is about weaker correlations. Next section, 21, practical strategies for psychological measurement. So up until now, we are exploring some fundamental concepts related to psychological constructs and how to measure them. Now, let's say you're tasked with actually measuring a psychological construct for a research project. In general, there are four main stages to the measurement process: defining the concept, defining the operation, implementing the measure, and assessing the measure. So in this section, we will examine each of these stages individually. Conceptually defining the construct. It is sort of obvious, but for effective measurement, Researchers must have a clear and complete understanding of a concept. Conversely, if you only have a vague idea of what you want to measure, such as memory, you would not know whether to have participants recall a list of vocabulary words, a set of photographs, a newly learned skill, or a past experience. Today, psychological scientists see memory as a set of interconnected systems, so you need to be more specific about what you mean by memory. For example, if you are interested in long-term episodic memory, asking participants to recall a list of words they learned last week makes sense, but asking them to remember to do a task later would not be as appropriate. The best way to determine how to define the construct is to review the research literature and see how variables are defined by researchers. Operationally defining the construct. After you have developed a conceptual definition of the construct you are studying, it is time to create an operational definition. This definition clearly describes how to measure the variable. Since many variables are abstract concepts that cannot be directly observed, such as stress, and observation is key to scientific method, conceptual definitions need to be translated into something observable and measurable, therefore quantifiable. There are usually multiple ways to operationally define a variable. For instance, stress can be measured by people's scores on a stress scale, such as the perceived stress scale, their cortisol levels in saliva, or the number of stressful life events they have recently experienced. Defining your variables may involve using an existing measure, which is usually recommended, but you can also create your own using an existing measure. It is always a good idea to use existing measures which have been used in the literature. This is because there are several points. A, you save time and effort by not creating your own. B, if the measure has been used successfully, this means it is valid. And C, you can compare your results with those from the literature. In fact, if there is already a reliable and valid measure of a construct, other researchers would expect you to use it unless you have a really, really good and clearly stated reason not to. Now, suppose you select an existing measure. How do you choose the best one for your research? You might pick the most common, most reliable and valid, most relevant to your construct, like the physiological stress measure if physiology is your focus, or the easiest to use. For example, 10 item personality inventory, or TIPI, measures the big five with 10 items. While less reliable than longer tests, it is useful when time for testing is limited. When researchers develop a new measure for research, they provide detailed descriptions in a published article so readers can use it in their own work. However, subsequent researchers often only give brief descriptions, so you may need to look at the reference section to find the original published article. Another resource to explore is the APA Psych Test website, which offers unpublished measurements. You will find a summary of the construct along with the details on reliability, validity, and a factor analysis if that information is included in the source document. Some records may also contain additional materials like datasets, answer keys, scoring sheets, and test manuals. Many assessment tools, particularly in clinical psychology, need to be purchased, including tests like intelligence assessments, the BDI, and MMPI. You can find information on these tests and how to access them in reference books, which are often available in university libraries. Instead of using an existing measure, you may want to develop your own, and this could be because there is no suitable existing measure for the construct you are interested in, or existing ones are too time-consuming to use. Alternatively, you may want to create a new measure specifically to test whether it performs in the same way as existing measures. That is, to assess conversion validity. In this section, we explore some general considerations for creating new measures that apply to all types of measures, including self-report, behavioral, and physiological measures. Now, be aware that most new measures in psychology are usually just variations of existing ones, so you will still want to consult the research literature for inspiration. You might consider modifying an existing questionnaire, creating a paper version of a measure that's normally computerized, or adapting a measure that's traditionally being used for a different purpose. For example, you know the Stroop task, right? Color words like blue, pink are shown on a screen in different colors, and the participants have to say the color of the font, not to read the words as quickly as possible. When the word and the font color match, reaction times are faster. However, when they do not match, people react more slowly because they cannot help but read the words rather than naming the color of the font. Researchers have used the Stroop effect to explore social anxiety and depression. In the emotional Stroop test, individuals with high social anxiety tend to be slower at identifying colors when the words have negative social connotations, such as stupid. Meanwhile, people with depression respond more slowly to words related to depression, like sad. It is always better if you use an existing test or modify an existing one. But if you still insist on creating your own measure, you will need to keep in mind the following points. First, make it simple. Make the new measure simple. Not all participants are as excited as you are about the study you are conducting, and their ability to understand and complete tasks can vary significantly. Provide clear instructions using straightforward language, which you can present in writing, reading aloud, or both. Two, include practice items. You should include one or more practice items to familiarize your participants with the task and give them an opportunity to ask questions before continuing. Three, keep it brief. Keep the measure from getting too long and make sure not to bore or frustrate your participants to the point where their responses become less reliable and valid. Four, include multiple items. Make sure to include multiple items rather than a single item. There are two reasons for this. A, content validity. Multiple items are often necessary to adequately cover construct. And B, reliability. People sometimes misunderstand instructions or questions or accidentally answer them incorrectly. These errors can offset each other when they are given an opportunity to answer multiple items, which contributes to better reliability. And five, finally, run a pilot study, the preliminary study. To obtain the most accurate results, test your measure with several people to ensure the instructions are clear, there is enough practice, and it is the appropriate length. Observe them as they complete the task, record their time, and ask for their feedback on how easy or difficult it was, whether the instructions were clear, and any other thoughts. It is best to identify and fix any issues with the measure before beginning large-scale data collection. Implementing the measure. Always refer to previous literature as a guide. For the most reliable and valid measurements, test all participants under the same condition in a quiet, calm setting. Although participants are often tested in groups, this can affect their responses, especially if the research question is related to social or group dynamics. When designing data collection, always consult previous research for guidance. Be aware of the participants' reactivity. Some participants may give socially desirable answers, behaving or responding in a way they believe are socially accepted. For example, individuals with low self-esteem often respond in a way that's socially acceptable, seeking to present themselves favorably to researchers rather than expressing their genuine feelings. Some people also respond in a way that they think is what researchers expect, a phenomenon known as demand characteristics. Furthermore, researchers' own expectations can influence participants' behaviors. Precautions. So, how can researchers minimize these kinds of reactivity? One, keep the process simple and straightforward so participants do not get frustrated. Two, guarantee participants anonymity. And three, hire a helper who does not know what hypothesis you are testing to reduce the impact of your expectations. Even if this is not possible, it's still best to standardize all research procedures. For instance, make sure you always read the same instructions word for word, or even better, play a pre-recorded set of instructions for participants. Evaluating the measure. Once you collect data, evaluate its reliability and validity. Examine if your data are consistent with that from previous literature. Test, retest reliability. Most research designs don't assess test, retest reliability because participants are tested only once. To measure it for a new measure, a study could test the same participants twice. Sometimes a study designed for another purpose still allows for this assessment. For example, a psychology instructor might measure students' attitude toward critical thinking at the start and end of the semester to see changes or correlations, indicating test retest reliability. Additionally, assess internal consistency using split half correlations or Cronbach's alpha. Criterion validity. There are several methods for assessing criterion validity. For example, if your study uses multiple measures of the same concept or different but related concepts, you can examine the correlations between these measures to see if they match your expectations. Also, a successful experimental manipulation can support criterion validity. If your data does not look right, it's common for your dataset to look different from what you expected. Don't worry too much about this. It happens more than you might think. Reading published research articles may give you the impression that those researchers always get it right when designing studies and collecting data, but that's not the case. They only publish their successful results, so we never see the unsuccessful ones. It's kind of like the millions of posts on social media every day. Compared to our normal lives, it seems social media, so-called social media stars, are always having a blast, right? However, the truth is that most of them only share the best parts of their lives, hiding the rest. I'm willing to bet many of their days are just as crappy as ours, but they just don't post about it. I don't have actual statistical numbers in front of me, but when you conduct research, more likely than not, you will end up not supporting the hypothesis, and that's completely normal. So if your data supports your hypothesis, that's great. But if it doesn't, don't be discouraged because it happens to researchers all the time. All right, so this concludes chapter 4.